goes to 1, and then 1/4, and then pi. So we're multiplying all those together. Your answer is pi over 4. Which I believe are the coefficients that we had earlier. But okay, y'all get the idea? So here's what I'd like for you to do out of your homework. We're going to put this section to rest for now. I would like for you in the 1.4 homework, I already asked you to do 11 through 23, right? So as a final result or a final set, add the last few problems to that. So go 11 through 28. You've already done 11 through 23. Go 11 through 28. So there's, what, 5 more problems to do? And then I want you to look at 49, 50, 51, 53, 54. So I'm having you skip 52, all right? And then 55, I'm going to circle it. That's a challenging problem. Not a lot of students can get that one without looking at a video or something. So if you want a challenge, take a look at that number 55. And that's it. That completes the assignment for 1.4. All right, we good? Any questions before we proceed? Yes?
I am, for some reason, struggling with the 4x over sine over 4x. How does that fit?
This right here equals 1 because, well, do you agree that these match?
Yes.
So junk, it's flipped. So you're allowed to have it flipped and it becomes 1. Now there's another formula, formula number 2, that has to do with cosine. It's not used as much, so I'm not going to stress it to you, but I want to at least show it to you. Right, so we have this formula up there about sine junk over junk. The similar formula for cosine looks like this. If you have x going to whatever, doesn't matter what it is, and you have cosine junk minus 1, and that minus 1 is not inside the cosine, so this is separated. Okay, so cosine junk minus 1, 1 over junk, the answer is 0. You cannot flip this one over. You know, with the sine, you could flip it and do it either way. For this one, it's this way and this way only. So as an example, just so you see it, if I had this limit x goes to, let's say, 2 of cosine of x minus 2 minus 1 over x minus 2. Look at that right there. Let's let x go to 2. What's 2 minus 2? 0. What's cosine of 0? 1. 1 minus 1 is 0. So we get 0 on top, and then 2 minus 2 is 0. So we get 0 over 0 here, right? But according to this, as long as this junk matches this junk, right? They do match. And see that we have a minus 1 here. Then as long as those match and they both go to 0, the answer to this is not 1, but the answer to this is 0. So this answer would be 0. I'm not going to test you on that. I'm just showing it to you because it would not be complete for me to just skip it. So there it is. All right. Again, I can't prove that to you. You have to take that on faith. All right, so we are going to skip 1.5 and come back to it. All right, and there's a reason why. 1.6 flows right, like we can go from 1.4 and flow right into 1.6. 1.5 would be like we're on a trip to Austin and we decide to like take a pit stop and get some snacks. That's what 1.5 is. It's something that's related, but it's its own topic. So I'm deciding to stay on the highway with limits. After we finish 1.6, we'll go back to 1.5, all right? Every semester I kind of do it different depending on how I feel. And most of the time I do skip 1.5. So I think in the lecture notes, I have it in that order. Like after 1.4 in the lecture notes, I have 1.6. And then after 1.6, I have 1.5. So that's the way I normally do it. All right, so we are now going to talk about limits involving infinity. And maybe it's worth us having a short conversation about infinity itself. So is infinity a number? Like when you think about the number line, is infinity actually a number? You know, you have all these numbers on the number line, right? 0 and 1 and 2 and right. So is infinity actually a number on the number line? No. What is it then? It's what?
It's all numbers. In one
It's
direction.
all numbers.
Like all numbers in one direction.
I'm not gonna say all numbers, because if you say all numbers, right, then we're talking about the entire number line. You would use this, or you would say all real numbers. That would include everything. Now there are an infinite number of numbers in there, right? But infinity is not a specific number. It's not every number. It is an idea, right? It is a concept. Infinity is this idea that something is growing without bound. Okay? That something is getting bigger and bigger and bigger and bigger and bigger. Yeah? So the idea here, infinity down this direction, is that something is growing and getting really big, positive, right? So growing, positive, right? Positive number. Big, big positive numbers this way. Now, this way is negative infinity, right? And that's a very, very big negative number, right? So that we have to get some language in order here, because when you're learning about numbers on the number line, we always say that numbers to the right are bigger than numbers to the left, right? So the number 2 is bigger than number 1. The number 1 is bigger than 0. 0 is bigger than negative 1. Negative 1 is bigger than negative 2. That's the way we order things normally when we're learning about the number line, right? The way I want you to look at negative infinity is that it's a very big negative number, right? A very large negative number. So, or not a number, but it's these numbers that are getting bigger and bigger and bigger, growing, but they're growing negative. Okay? When I say small numbers in this class, I'm talking about numbers that are really close to 0. I'm not talking about numbers that direction. I'm talking about numbers that are close to 0. So these are small numbers. These are big positive numbers. These are big negative numbers. We clear? Just so that when I'm talking, you understand where we are. So what we're going to do now is we're going to talk about limits again, but this time somehow infinity is going to be in here. Okay, this idea of infinity is going to be within these limits. So there's two different separate topics when it comes to this section. When it comes to infinity, there's two separate distinct ideas that involve infinity. The first idea is this idea of infinite limits. Infinite limits. So here's what we've got. I want us to take a look at a graph. That is the graph of the function 1 over x squared. So if I graph the function f of x equals 1 over x squared, right? Do you all agree I cannot plug 0 into this? F of 0 is undefined, right? What would happen if you plug in 0? You get, what is on top? 1 on the bottom, 0. 1 over 0, is that bad, use algebra? Is that what I told you is bad algebra? What did I tell you is bad algebra? 0 over 0, right? I have not talked about what happens when you get 1 over 0, have I? I haven't talked about it. It's only been 0 over 0, right? So now, in this, if you look at this situation, if I were to take the limit as x goes to 0, right, of that function 1 over x squared, if I tried to do this limit, the first thing I would do is direct substitution. I get 1 over 0, which is undefined. So this would be 1 over 0, right? That is, I don't know, right? I don't know. It's not bad. It's not algebra. I don't know yet. But what can you tell from the graph is happening? If we approach 0, and notice I didn't put a plus here, right? Or I didn't put a minus, which means you have to approach from both sides. So what happens as you approach 0 there from both sides? It heads up forever, right? This asymptotic. It has a vertical asymptote there. So as we head from the left, we're approaching 0. As we head this way, right, we go to infinity, positive infinity. And as we go this way, it heads to positive infinity as well, right? Yeah? So we didn't have 0 over 0. We actually had a number over 0, didn't we? This was a number, not 0, a number over 0, and we had an asymptote. I wonder if that's always the case. Should we look at another example? That graph is the graph of f of x equals one over x. Not 1 over x squared, that's 1 over x. Is this function defined at 0? If I try and plug in 0, what do I get? Undefined, right? Undefined. So what is the limit then as x approaches 0 of this function 1 over x? What do you think? What do you got, sir? What do you think?
From the left, negative infinity, and from the right, positive infinity.
Okay, so from the left, if we come into, see here I didn't specify, did I? So you have to check both, right? So if I come in from the left, I'm headed down to negative infinity on the y-axis. But if I come in from the right, I'm headed to positive infinity, aren't I? But again, when we do this limit, we get 1 over 0, right? Which is a fixed number, not 0, not 0 over 0. It's a number over 0. And I have an asymptote again, don't I? I have a vertical asymptote. So I'm trying to think, maybe this is always going to happen. That when I have 1 over 0, or sorry, number over 0, maybe I'm always going to have an asymptote. Maybe. Now, what do y'all think the answer to this limit is? Because from the left it was negative infinity, from the right it was positive. So what do you think the answer is? Does not exist. So the correct answer to this limit is that it doesn't exist, because from the left it's one thing, from the right it's something else, right? And for a limit to ever exist, it has to be the same from both sides. Let me give you another one. Let me see if I have, yeah, no, I'm not ready for that. I think I'm going to Desmos this one. Okay, what we're looking at here is the graph of the function. This is the graph of the function f of x, in case you can't see it there, is x over x minus 3. Okay? Take a look there. And can you plug 3 into this? Are you allowed to plug 3 into that function? No? Right? F of 3 is undefined. Right? F of 3 is undefined. So can you all see 3 here? Let me zoom in a little bit so you can actually see 3. Where is it? There it is, finally. Does anyone use Desmos ever? Yeah. So if you're in Desmos and you hover over the y-axis like that and you hit the shift key, you can change the scale of the y-axis without changing the scale of the x-axis. Same thing with the x-axis. If you hover over it and hit shift and drag, you can change its scale without changing the scale of y. Of course, if you just use your scroller, it zooms out and zooms in. Just FYI. All right, here we go. Okay, so I'm putting you to sleep. I'm putting you to sleep, so will you help me? What's the limit of this function as you approach 3 from the left? Sorry? Let me put the function up here. How are you getting that answer? You're approaching 3 from the left. What is the function doing? Going to where? We're approaching 3 from this side. So you're on this function walking, right? And you're going towards 3. And where are you headed? The y value, right? So that is negative infinity down there, right? Negative infinity. So we're headed to negative infinity from the left. How about from the right? If we approach 3 from the right, where is it headed? Positive infinity. So does this limit exist? No, this limit does not exist, right? This limit does not exist. However, we have a vertical asymptote, don't we? Again, we have a vertical asymptote. What happened if I tried to plug 3 into this? What would have happened? 3 goes in here. What do I get? 3 over what? 0, right? Not 0 over 0, number over 0. I'm trying to show you, I'm trying to make a correlation in your mind here. I'm trying to get you to see that when we have a number, not 0, over 0, we're getting an asymptote. You see that? A number over 0, we seem to be getting an asymptote. Let me change one thing on this. I'm going to change this function. What I'm going to do is I'm going to take this and I'm going to square the bottom instead. So I'm going to take this and I'm going to square it.
Is it always going to be a vertical asymptote?
Yes. I'm going to put this is going to be in the notes, and I will do it. So I will show it to you formally. So I'm just going to change this now real quick. All right, so there's that function again. All right. So let's just check what happens when you let x go to 3. You get 3 on top, and again, 3 minus 3 is 0, so you still get 0 on the bottom, don't you? But what's happening from the left and right? It's a little different. From the left and right, you've got both sides going where? Positive infinity. So your answer here should be, instead of does not exist, this should be positive infinity. Are y'all catching this? Yes?
If one goes to negative infinity and one goes to positive, is that when it does not exist?
Okay, so the question is, if one side goes to positive infinity, the other is negative, then the answer is does not exist. That is correct. Okay? Unless I'm only asking you to look from one side. If I'm saying only look from the left and it goes to positive infinity, then your answer is positive infinity. But if I don't put a plus or minus here, you have to check from both sides. So you need both to either go to positive or both negative for it to exist. Yes?
Before we're talking squared, is it both does not exist and undefined, or just does not exist?
So you're asking for this one here, right? For that one there. If I do that limit right there, that limit does not exist, right?
Yes.
We use does not exist when we're talking about the limit. We only use undefined when we're talking about algebra. Try to plug 3 into the function, right? If you try and plug 3 into the function, it's undefined. The limit doesn't exist. So those are two different. We reserve this word for the algebra question. We reserve this DNE for the limit question.
So we don't need to plug in 3 then, because when we plug in 3, it's 3 over 0.
3 over 0, right, tells us there's a problem.
Yeah.
So,
Then we can fix it.
Can-
I'm saying it doesn't exist.
well, it's going to depend. It's going to depend. Right now, here's the big thing I want everyone to be able to see. Before I started talking about this, if we had 0 over 0, it was bad and we used algebra, right? Okay. Now what I'm trying to get you to see is we're getting something that's not that. We're getting a number over 0. We keep getting that, right? A number over 0, number over 0. And every time we get it, we seem to have a vertical asymptote, don't we? Okay, and that's the case all the time, no matter what, all right? As long as you get a number over 0, you're always going to have vertical asymptote. When you have a vertical asymptote, either both sides do opposite things or both sides do the same thing. And so it's going to be up to us to figure out which of those cases it is. Do y'all have that sheet that I handed you that had the 4 boxes on it, the limit summary? Get that out real quick. Do you mind if I peek off yours real quick? Bottom left-hand corner. Bottom left-hand corner. Do you see what it says down there? Bottom left box. It says fixed. And what does it have? A little plus in the top right corner? Yes? Fixed plus over 0. Do I put 0 plus there? Yeah, 0 plus equals infinity, right? That's what I have. So what this is telling you is that if you take a limit and on the top you get a fixed number that's positive. Remember we got 3 a second ago? That would be a fixed positive number. And then your bottom goes to 0 and it's positive as well. Now that we don't know if it's positive or negative because 0 is not positive or negative. But if you can determine that this number down here is positive as well, then your answer is going to be positive infinity. And then I give you, what, 3 more? If you have fixed positive over 0 negative, then it'll be negative infinity. And then if it's fixed negative over 0 positive, it'll be negative infinity. Right, you see all 4 there? This is now like the summary for these scenarios. And what we want to be able to do is use this now to get to calculate some limits. The pictures were just to get you to see, like, yes, we have vertical asymptotes. We're either getting infinity or negative infinity when we come in from different sides. Let's actually do like a real problem. Yes?
How do you tell if 0 is positive?
Exactly. How do you tell if 0 is positive or negative, right? How do you do that? Let's do an example. I'll show you. Yeah, let's just do that. All right. This is our first example with this. Limit. Let's let x approach 4 from the left of 2 plus x over 4 minus x. Now, I've given you a one-sided limit. What do I mean by one-sided limit? I'm only asking you to come in from one side, right? All right, let's check to see. For every limit, what's the first step? Direct substitution. So when you direct substitute, you're plugging in 4, not negative 4, right? This is positive 4. So we're plugging in 4 at the top. What do we get up top? 6, okay, and on the bottom, you get 0. Ah, okay. It's not 0 over 0. It's a fixed number over 0, right? It's a fixed number over 0. So I'm actually going to write that out. This is a fixed number over 0. The only thing left for me to determine is whether or not these are positives or negatives, if the top is positive or negative. Because I know there's an asymptote here. I know there is. So I know that as I come in, I'm doing like this, or I'm doing that, or I'm doing this. And I'm only coming in from one side. So I just got to figure out, is it going up or down? Make sense? So tell me about the numerator. It's 6, right? That's a fixed number. Is it positive or negative? Well, 6 is positive, right? So this is a positive number. Now I'm approaching 0, right? On the bottom, we know that the bottom's getting smaller and smaller and smaller, because if I plug in 4 here, this goes to 0. The question is, are these really, let me back up. When we take a limit, we're letting x get really close to 4, right? Really close to 4. We're not letting x actually be 4. So if I take a number that's really, really close to 4 from the left side of 4, and I plug it in here, am I going to get a really, really small positive number or am I going to get a really, really small negative number? That's the question. So one way you can do this that I like is to just draw a number line. Here's the number 4, right? And we are approaching 4 from which side? The left side. So I'm coming in from here like this, right? Can you think of a number that's here to the left of 4 that's really close to 4? 3.9, right? What would be a number closer? 3.99, right? Another one, 3.999, right? So this is where you're just going to pick something where you feel like you're close. 3.9, I'm going to go 3.99. That okay? That's kind of close to 4 from the left side. Agreed? What would happen if I took this number and I plugged it in right there for that x? 4 take away 3.999, or sorry, 3.99. 4 minus 3.99 would be a small number, right? Positive or negative? It'd be positive, wouldn't it? What if you did 3.999999 and plugged it in there? 4 minus that would be really small, but still positive, right? So it's just a matter of me thinking through this, what's happening, that when I come into 4 from the left-hand side and I do this arithmetic, I know now that my bottom is going to be a small positive number. I already know it's an asymptote, so I know it's going to infinity or negative infinity. I just need to know which one. And what can you tell me? It's got to be positive infinity, because the ratio of two positive numbers must be positive, right? So my answer is positive infinity. Here's kind of another way for you to look at it that I think is worth it. Imagine you have a number on top, right? A number on a fraction that stays the same, it's fixed. And imagine you start dividing it by small numbers. What happens when you take a number and start dividing it by smaller numbers? Does that ratio get bigger or smaller? So if I have a number like 6, and I start dividing it by smaller numbers. So what's 6 divided by 1/10? Do y'all agree 1/10 is kind of small? Wouldn't I flip that up and it becomes 60? Right? Wouldn't that become a 60? What if I kept the 6 here, but now I went even smaller and I did 1 over 100? See how that number's gotten smaller? That would be 600, wouldn't it? And what if I kept the 6 where it is and I did 1 over 1,000? Flipped it, it would become 6,000, right? So if you have a numerator that's fixed and your denominator gets small, the ratio gets huge, which is what's happening here. My numerator is staying close to 6. My denominator is getting really small, but positive numbers, so I get a ratio of two positives, gives me a large positive number. Yes?
So if you change the direction that we were going in,
It's going to change your answer.
so then what do you change?
Let's do it. Let's do it. That's exactly what I'm doing now. All right. I have a couple of minutes. So let's do the same problem, but let's come in now and change it, and let's come in from the right-hand side. Okay. So I'm approaching 4 from the right. All right. What do we get when we approach 4? So direct substitution first, you get 6 over 0. Same thing we had before, right? So that hasn't changed. I know that it's a fixed number on top. I also know it's positive, don't I? Because 6 is a positive number. There's no changing that, right? 6 is positive. Here on the bottom, I'm approaching 0. So the thing I don't know about this is whether or not I'm approaching 0 through negatives or if I'm approaching 0 through positives, right? I don't know. Which of these is it? I know the numerator is positive, but I don't know what the denominator is. Is it a small positive or negative number, right? So now I'm going to go and draw a number line again. Here's number 4. This time I'm approaching from the right. So what's a number that's slightly to the right of the number 4? 4.01, something like that? 4.01 would be an example of a number. You could do 4.001. 4.0001, right? You could have and then like 100 zeros, 1. But the point is that when you take that number and you plug it in here, what's going to happen? 4 minus that, positive or negative? This time negative, right? Because this number is slightly bigger than that number, And so when you subtract it, you're going to get a tiny little negative number, which allows you to conclude that this is a very small negative number, and the ratio of a positive divided by negative is negative. So your answer is negative infinity. I want to do another one. I do have enough time. Limit x approaches -3 from the left of x squared plus 1 over x plus 3. The first step for every limit is to just substitute, right? So put your -3 in here. What's -3 squared? 9, add 1, 10. Okay, you got a fixed number on top, don't you? Not only do you have a fixed number, it's a positive number. Oops, I'm just going to put 10 here. Right? And on the bottom we get 0, yes? So your fixed positive on top over 0. We just don't know if it's a positive or negative on the bottom. Do you all understand that right now I am sure that either this answer is infinity or negative infinity? Do y'all get that? It's just a matter of determining what's happening on the bottom. So to determine the sign on the bottom, I'm going to draw a number line. And I'm putting what number on here? -3. And I'm coming in from which side? The left. And I'm going to carefully think of a number that's right there. Carefully. -2.99. That's the common mistake. You have to be careful here. That's why I gave you this problem, because this is, think about the number line. It's 1, right? It's 1, -1. Then here's -2, here's 2, right? Here's -3. What's on the other side over here? -4. So if we're coming in from here, you're actually going to be picking a number like -3.01, not -2.99, right? This gets people on an exam. They'll plug in -2.99, and that means they're on the wrong side and everything's going to be off. Okay, so just be careful. You don't have to worry about that when you're in the positive numbers, because everything works the way you think it works. It's just you have to be careful on the negative side. Okay, so an example would be what? Negative what? 3.01 would be an example. You take that number, you imagine plugging it in right there on the bottom. -3.01, add 3, what do you get? Is that positive or negative? Which one is bigger? Which of these two numbers is bigger? Like in terms of like an absolute value. This one's bigger, right, than that? So whatever our answer is should keep the sign of this one. So it should be a negative. And then you have a ratio, negative infinity, right? Okay, I'm out of time. But there's some problems in 1.6 that you can at least